Let's start with our amazing Matz. Our opening keynote speaker is, we all know, Yukihiro Matsumoto, also known as Matz, who is a Japanese computer scientist and software programmer, best known as the chief designer of the Ruby programming language and its reference implementation, Matz Ruby interpreter. His demeanor has brought about a motto in the Ruby community: Matz is nice, and so we are nice, commonly abbreviated as Minaswan. As of 2011, Matsumoto is the chief architect of Ruby at Heroku, an online cloud platform as a service in San Francisco. He is a fellow of Rakuten Institute of Technology, a research and development organization in Rakuten Inc. He was appointed to the role of technical advisor for Vasily Inc. starting in June 2014. So many really difficult words in English. I'm trying my best, but let's give the turn to Matz. Please welcome.
Hello, this is Matz, the creator of the Ruby language. Today, I'm going to talk about the Ruby 3 and beyond. The Ruby 3 was finally released on December 25th, 2020, last Christmas. We have improved the language a lot since it was the major release. So the Ruby 3 was more concurrent and more performant and more productive. For concurrency, we added Raptor, which is the Ruby version of the Raptor model. And for performance, we added the Jet compiler, and we have improved the garbage collector. To be more productive, so we added the new tools like to support the static typing, which is the tool named RBS and the type Prof. And the three major goals of the Ruby 3.0 release was to be compatible and to be faster and to be better. So let me explain them one by one. For the first, for compatibility. Almost all 2.x programs run on 3.0, so that we care very much about the compatibility, so that you don't have to modify or upgrade your application to migrate to Ruby 3.0, because compatibility matters very much. We have learned lessons from the Ruby 1.9 tragedy. The Ruby 1.9 was introduced in 2007, and we made some incompatibility then. For example, we added the encoding features to support the Unicode better. So that the behavior of the string class was changed very heavily, so many applications need to be upgraded to migrate toward Ruby 1.9 from 1.8. Some people in the community stayed in the older version 1.8 for a long time, so that we suffered some kind of the community split for more than 5 years. The similar situation happened in other languages as well. For example, the Python 3 made some incompatibility change from Python 2, I mean. So that some people decided to stay in older version Python 3. the PHP 6 was the very drastic change, and the community refused to migrate to the newer version. So that the project of the PHP 6 was cancelled, and then they started all over again from the older version PHP 5, then started the PHP 7, so that we have no the public released PHP 6. Very similar things happened in JavaScript. The Ecmascript 4 was very challenging upgrade, but they've added classes to the JavaScript instead of the prototype-based object-oriented programming, and they added many other new things. But the community refused to migrate to refused to accept Ecmascript 4, so that the project Ecmascript 4 was cancelled. They started again toward the Ecmascript 5, so that we have no public release of the Ecmascript 4. And yeah, interestingly, so that the many things in the Ecmascript 4 was reintroduced into the Ecmascript 6. So they are too harsh. So that the incompatible changes are unacceptable for the community. Yeah, that's it has a reason. So that language designers like us, so that we make mistakes. We have mere mortals, so that we make many mistakes in the past. So that if it's possible, we want to fix those mistakes in the past. So that we want to have the better programming language, more simpler, more consistent, and a more intuitive language. So that we want to fix those mistakes, and if it's possible, and if we have chance, and the major version upgrade, like the Python 3, the PHP 6, and the Ecmascript 4, those major version upgrade was very good chance to fix those mistakes. But fixing those mistakes sometimes introduce the incompatibility. So those versions, 1.9 is not the major release, but the feature-wise, it was the major change. So those changes were these major version upgrade sometimes introduce the major version upgrades, and then that makes our users pain. That it's a little bit different in between applications and languages. So the humans can accept the changes. And if the color of the button or the place of the button is changed slightly in your applications, users can be easily adapt. But if you see the incompatibility or changes in the language, your application do not accept those changes automatically, so that you have to migrate to the new language. So that's where we see some kind of the contradiction. So that programmers love new things. And if we don't make any progress, so that we got bored, so that we are not interested in the language any longer, so that we are moving towards the new technologies like whatever, TypeScript, Scala, or Rust or something. So that's why, so that we are going to make changes, we are going to make progress, and then the major version seems to be a chance, the great chance to change. but it can be the great chance to break existing code. And, although programmers love new things and the changes, but programmers at the same time hate pain forced by new things. So that's why compatibility matters. That's why we keep compatibility for Ruby 3. Compatibility learns we have learned lessons. Progress, we have to make progress without breaking the past. We should keep compatibility. And we try to keep full compatibility. So that we try to add new features introduced without any breakage. Except for a few bug fixes, because some programs can rely on the buggy behavior. So that's where I can only say I'm sorry. Yeah, but we try our best. We've tried our best to keep compatibility for Ruby 3, Ruby 3.0, and later afterwards. So that we try, we will, and we have, and we will try to keep compatibility. Second, performance. We have improved the performance of the Ruby language because performance matters. So that we have introduced the JIT compiler, which dynamically generates native code. The JIT compiler in Ruby is called named MJet. It was introduced since Ruby 2.6, and we had some performance goal for the Ruby 3.0, which is called the Ruby 3.3, which means the Ruby runs 3 times faster in some benchmarks. Typically, the OptCarrot. OptCarrot is the CPU intensive benchmark. Which runs the old Nintendo games, Nintendo game, and they count the frame per second. But Ruby 3.0 makes Rails application faster yet, and we are improving. At the time of the Ruby, the first version of the MJet, which was introduced in 2.6, it was the Rails application runs far slower than without Jet. But since we have improved a lot in last 2 years, so the Rails application or any web applications, for example, the Sinatra or something, and can run as fast as without Jet. Its performance is similar. That's kind of silly. That kind of sounds silly, but it's for us. It was a great improvement. We are improving, and we have some plans to improve the performance from the Jet even further. So that stay tuned. Concurrency. We have introduced concurrency for the sake of the performance. Back in 1993, which I started the Ruby programming, developing Ruby. So the computer back then, most of the computers have only one core per machine. So there is no parallelism in most of the computers back in 1993. So the Ruby concurrency was designed to make some kind of the abstract concurrency, no parallelism. So the performance is not a priority, not a goal back then. But the times passed and the situation has changed. The many machines has more cores, 2 cores, 8 cores, 64 cores, or even more. The present time, we have to use small cores to improve the performance. But for the faster execution, concurrency is the key. But we have something named GALE, which is the Global Interpreter Lock. So that basically the Ruby virtual machines runs at the single thread. So that at the time, even with the multiple threads running, because the thread-safe runtime, thread-safe virtual machine is hard, especially for existing programming languages. The Ruby virtual machine was originally designed and implemented in the single-threaded model, so that it's quite difficult to make them thread safe, and that can be run in parallel. So to improve the situation, so that we try to introduce the fine-grained lock, so that we lock the virtual machine when absolutely necessary. But the attempt was failed because we have so many the critical regions, and the locking and unlocking has cost, so that it makes Ruby significantly slower, especially in the single-threaded mode. And even in the multi-threaded mode, the performance was not improved. So for the sake of the due to the locking unlocking cost. So that our new ideas, we have introduced a new concept, which the one is the async fiber, the second is Raptor. Async fiber is the something to improve the I/O heavy task. Think of the async and await in other languages like Python, JavaScript, or even PHP. For example, the Node.js itself is single-threaded, but it is very performant due to the one reason is the V8, the virtual machine, which is the core of the JavaScript, is very fast, and the other reason is basically every operation is non-blocking in Node.js. So for Ruby 3, we introduce the async I/O, non-blocking I/O with fibers. So we use fibers to implement the non-blocking I/O, so that we don't have to introduce any new keyword like async or await in the language. And by using async fiber, the Ruby virtual machine automatically switch context on I operations. We need to specify a scheduler to create the async fiber. So the async fiber does not use multi-cores, but due to the faster context switching, it could have the faster performance. For example, the application server named Falcon, which is the counterpart of the Unicorn and the Puma, which runs pretty fast, and it can handle the so many connections at the same time, even millions of connections at the same time. due to the fiber. Falcon is based on fiber, and actually the author of the Falcon is the maintainer of the Asian fiber, which is the Samuel Williams, who is very brilliant. So to improve the IO heavy operations, we can use the Asian fiber. So how can we use the multi-core? How can improve the CPU intensive tasks? That's Ractor is our answer. Ractor stands for the Ruby actor. It's designed for the CPU intensive task. Ractor is basically the isolated object spaces, so that we basically don't share objects between Ractors. So the communications should be done via channels. So as a result, we don't share any state, any object. So that's kind of the limited sharing. So the Ractors can share objects which are immutables, and recursively frozen, which is basically immutable, and then the class and modules for convenience. So that to access the class and the modules, we need fine-grained lock, so that it could be the performance could be slower when you access a lot of classes and modules or the constants. But basically, those immutable and recursive frozen objects can be shared, so that each Ractors can be executed in parallel. So that you don't have to worry about the GIL between Ractors. So that we can use the multi-core using Ractors. This is a small example. Tarai is the the recursive benchmarks, and then for the first the benchmark, we call the Tarai 4 times in sequence. And then the second version is the parallel version. We create the 4 Ractors and then calls 4 Tarai in parallel. This is the very artificial example, but this example runs nearly 4 times faster. Actually, the 3.8 times faster. The parallel version runs 3.8 times faster on my machines. So that's quite nice. So that we can improve the performance using the JIT or other improvement, and the Ractors and Asian fiber. We 3.0 introduced some language improvement as well to better error bug handling. So that actually right now it's the time of static typing. The new popular programming language like Go, Rust, Swift, and other things are all static typing. But and then the older programming language which were popular, the PHP, Python, JavaScript introduced the static typing. PHP introduced the type annotations, and Python, PHP, which is type hints, and Python introduced the type annotations, and TypeScript is the static typed version of the JavaScript. It seems that everyone goes static typing. The problem is, shall we do that? Shall we go to static typing? I don't think so. We don't want type declarations. We want more precise code. I know the benefit of the static typing, so that we want more precise checks, and we want to detect error earlier. But and we want code completions, so that so we are going to introduce the static typing, kind of static typing to the language without adding any syntax. That's how we go. We have introduced the three things: Ruby signatures and type prof and the static type checkers. The Ruby signatures, RBS for short, which is the TypeScript D.TS counterpart of the TypeScript, which is the new language to describe the static types of the Ruby libraries. This example defines the class foo, which has two methods. The foo returns nothing, and 2s returns strings, and 2s may take integer as an argument, and returns string as well. The RBS only describe the types, not the behavior. And then Ruby 3.0 ships with the RBS for the core. So every Ruby library, like a string, array, hash, and ranges, so the many classes in the core is type of the methods described in the RBS and shipped with the Ruby 3.0. We can use the information from the RBS to implement the type checkers or beta ID or beta code completions or the type signature pop-ups, and then those things can be implemented. I don't say the Ruby 3.0 will ship with those tools, but it is possible to implement or improve those things. Okay. Type prof is another tool shipped with the Ruby 3.0, which does the naive type checks and generate RBS for your applications. Let me see. This is the silly Ruby example. Defines the class foo, which has the two methods, foo and bar, and then the method called the method foo. The type prof does some kind of the abstract interpretation. So let me foo instance of the foo class is created, and the foo method is called the argument with integer, so that the foo argument a of the foo method is integer. Then the integer has a plus method, so the a plus 2 equals to integer, so b is integer. So the foo method returns b. So the return value of the foo method is integer. The bar method is called with the integer 42, so the argument of the bar method is integer. But the integer plus strings is not defined. This is type error. The type prof reports the type error at this line. So since error occurred in the bar method, the return value of the bar method is or the type information of the bar method is not defined. So that from the abstract interpretation of these programs, we can generate this RBS. We have the class foo and the method foo that takes integer, that returns integer. But we have no information about the bar method, which has error. That kind of things. Since we have the RBS, the signature of your applications, you can type check your applications, or maybe your application, the type information of your application can be upgraded by hand. Since the type prof is incomplete, for example, RBS can describe the interface like the abstract type in the Go language sense, but the type prof cannot be extract those kind of the interface yet, and some kind of the generic type can be described in the RBS, but it is so difficult for the type prof to extract the generic types, that kind of things. So that if your class has those kind of the generic class, so that you have to upgrade your RBS of your application by hand. And in addition, we want even better Ruby, so the Ruby 3.0 introduces some new syntaxes. The major one is the pattern matching and the numbered block parameters. The pattern matching was introduced to 2.7, and then instead of the retrieving and the checking the each element in the structure or something like that, that we can do like this, so that you can pass the JSON file, then find the Alice, the person, people data whose name is Alice, who has the child named Bob, and the print age of the son Bob, or something like that. It's quite straightforward. In addition, we introduced the one-line pattern matching, which can be used as a right-hand side assignment, or can be used as a multi-assignment, or can be used as a decomposition. Yeah, that's quite handy. So that, yeah, and then we also introduced the numbered block parameters like this, so that instead of declaring in the block parameter names in the pipes, so that we can use the _1. And then if you abuse it, you can write some kind of the unreadable code. The _1 is very cryptic, but for the shorter block, it's quite handy, like this. Okay, I have explained about the Ruby 3.0, so that I will explain about what will happen beyond Ruby 3.0. So that Ruby 3.0, we need to seek for completion after Ruby 3.0. Some new features may be buggy, especially reactors. So that reactor was very tough development, so that we have hard time developing it, but the concurrency itself is quite difficult, so that we have to improve the reactor a lot. We need improvement. So the Ruby 3.1 will be more conservative release, more suitable, so that we are not going to add new things like a Ruby 3.0, but we fix many bugs, and then we improve the performance, and then we refactor them for the better maintainability, so that we will see less bugs in the Ruby language. Also, after Ruby 3.0, so the supporting feature will become more and more important than the language itself. So the Ruby static typing is supported by tools, remember, the RBS, type prof, and the static type checkers. The tools are more important today. Back in the Fortran days, language is everything. It is the development environment, it is the the performance tuning, everything. But right now we use many tools, and the tools are more important. For example, we have the tools named the Solar Graph, which is the the language server protocol server, and then we can have the some kind of the IDE support from this server, and then Solar Graph. Yeah, Solar Graph itself is a third party supported by the community, but we can help them by providing the RBS information and AST generation or something like that. So that we want to help them to implement a better support. Solver is the static type checkers. And Rubocop, yeah, many of you use Rubocop, and Rubocop is a great tool, but we can improve Rubocop a lot in the future because the better tools enable the better user experiences. So we need more tools, like better tools, like type checkers, formatters, language server protocol tools, performance tuning tools, and debuggers. The Koichi is one of the core developers, is now working on the debugger, the Ruby 3.1, which will be released in the next Christmas. Will have the better debugger, but we can improve the other tools as well. And then performance improvement is the great theme of the future development of Ruby. Ruby is basically a human-oriented programming language, so the performance is not our first priority. But remember, still performance matters, so that many people care about the performance of the Ruby. So the benchmarking game is pretty popular among the programmers. The Ruby 1.9 was released in 2007, and we introduced some incompatibility, as I told you. But at the same time, Ruby 1.9 introduced a new virtual machine, which codename was Yelp. And then I'm sorry. Back then, some refused to migrate to 1.9, and then we suffered the community split for more than 5 years. But then, until the Ruby 2.0 was released in 2013, so that those kind of the community split was very compared to the other language like the Python. Yeah, they suffered similar problem. And then Python 3 was released in 2008, and then Python 3 was officially died in the last year. So that they suffered the community split for more than 10 years. So that means that we suffer for 5 years. That is a long time to suffer, but it's shorter than Python. What's the difference? I think, my understanding is the Ruby 1.9 had Yelp, which was far faster than 1.8. So that developers are willing to pay the price not for the cleaner language or better language, some say, but for the faster language. If your application runs 2 times faster, they are willing to pay the price. In that sense, performance matters. Yeah, performance heals problems. Performance from repetitions. And actually, we love performance comparison. comparing similar same program in this language A and language B, and language A is faster or something like that. Yeah, that could happen in many cases in the blog posts and articles. But how we measure the performance? The programming language has many aspects, so that we cannot assume how they are used. Some people use programming language in implementing, developing games. Some people use some people develop web applications. Some people use language for scientific computing. Some people does text processing. So that how we measure performance in general. Unfortunately, it's by micro benchmarks. Calculating Fibonacci numbers or factorials or word counting. Are they related to the real world performance? No. No. Yeah, actually, there are very few cases the real world performance is the bottleneck. Micro can be a bottleneck in the micro real world application can be measured in the micro benchmarks. But it's fun. It's fun story for idle chat. But people make decisions on false assumptions. Yeah. So the performance forms reputation, and actually the Ruby is fast enough for most of the cases. Many services like GitHub, Shopify, Instacart, or many other services are implemented Ruby. Yeah, I don't know they have any performance problem, but if they have very serious problems, they try to migrate to a new language, but they still using Ruby. That means that the performance can be manageable, acceptable for those big services. So the performance forms the reputations, but reputations are formed by the micro benchmarks. Okay. We will improve the performance not only for real world applications, but for micro benchmarks too. People trust micro benchmarks. Yeah, sadly. So that we also try to improve the performance of the micro benchmarks as well. For your information, that recently in the Python community they try to make Python faster. This year, the Guido van Rossum, the creator of the Python programming language, declared to the workforce to make C Python faster, and then they try to make Python faster by factor of 2 or factor of 10. And then they adopted something named the Shannon plan, which is the promises 5 times in 4 years. And then they started open discussions, and then they try to do new things, and then like this, that means Python tries to run 5 times faster in 4 years. Python 5 by 4? I don't know. 50% faster each 4 years. 1.5 powers to 4 means the almost 5 times. They are trying to implement the adaptive bytecode interpreter, beta frame stack, zero overhead exception, faster integer internals, just-in-time compiler to implement the Python, C Python, 5 times faster. Yeah, great. Actually, some of them have already done in Ruby 3. For example, the boxed integer and the beta frame stack and the super operators and the JIT compiler. And then, yeah, actually, I have to say I am suspicious of their estimations from our experience. But no one can tell about the future. So that actually, I believe they are smart, and then they are very powerful, and then they are funded by the big corporation like Microsoft. And but I will be happy if I'd be proven wrong. And we will try improve the performance of Ruby language too. Anyway. So that I declare the Ruby 3x3 again, revisited. That means the Ruby 3.x will be 3 times faster than Ruby 3.0. I don't know it's possible or not, but it's ambitious. Our performance improvement continues. We are going to have the beta JIT compiler, which can be achieved by the lightweight JIT. Currently, we have 2 attempts to implement the lightweight JIT. One is the mail from the Vladimir Makarov, who is the original author of the MJIT. And the second is the YJIT from Maxim, from Shopify. Or even we can implement the multi-layer JIT, which is the baseline is executed by the bytecode. The bytecode virtual machine. The most of the methods, which is hot, it can be compiled by the lightweight JIT compiler, and then some fewer very hot method can be compiled with the MJIT with the fully optimized code. For example, the virtual machine in JavaScript virtual machine in the Chrome or the Firefox does provide those kind of the multi-layer JIT, so that we can do them as well. Also, we are going to improve the performance of the Raptor, which is the NM Raptor. Currently, we have the 1 native thread per Raptor, but maybe we can have the isolated providing n Raptors on the M native threads, which M is almost for the number of the core, so that some Raptors can be, very actually the user level Raptors, which can be more lighter context switching, and then as a result, the faster parallel executions. That could be more lightweight than the current one by one Raptor. So the n Raptors on M native threads. So as we said, Ruby 3.0, 3.1. Ruby 3.1 will be very conservative. Would be very conservative the release. That we are not going to see much language enhancement in the near future. But for the future, I have some vague ideas. The one is the beta packaging. The other is the code attributes. Beta packaging means Ruby requires is not isolated, so that everything code from required can be seen from global. But other language like Python, Java has the some kind of the packaging, so that you have to explicitly import expose the name, so that from the packages, from the modules, that can be you know that can be, say, organize the namespace. The, it probably it's better to provide a way to isolate constant and variable namespace, so that you have to uh, worry less about the name clash or something like that. Yeah. But it's a vague ideas. I have no concrete syntax, concrete behavior, but it's just idea. The second one is the code attribute, so that we can provide some kind of the simpler metaprogramming, metaprogramming with nicer appearance. This is example. This is not the final version, but this is just idea. Okay, the class foo has the attribute frozen, so that this class is frozen. And then method toString has the attribute private, so that this method is private. It should be private or something like that. So that adding those comment-like attribute, so that we can avoid some kind of the ugly metaprogramming. I have tons of these silly ideas, and some of them are implemented in the language, and some of them just abandoned. Anyway, we will keep moving forward as we have always tried. So that we try to improve the language for last 20, nearly 30 years, 28 years or something. We improve the language to create a better world, to make world better. That we want to help you developers. So we want to make Ruby users, Ruby programmers happier. We want developers enjoy programming. And this is my or our gift to the world, to the developers. And I think you can join us. You can join us to make the better world. You can be a part of the Ruby community, and you program in Ruby, and you enjoy the programming, and your result, your product will make the better world. So that I hope you enjoy the programming, and I hope you enjoy the rest of the conferences. Euruko. Thank you. Bye bye.
Thank you, and thanks for the sponsors for creating this event and making it possible. In case you arrived a little bit late, you can find the stream chat on the left side of the navigation. Just click the stream open there and you find the chat where actually we have quite a lot questions and comments, and this is what really makes a community. Thanks for the discussion, but I think we have a couple questions also for Matz. Do we have a Matz in line? Yes. Welcome, nice to see you, and thanks once again for your keynote. We have a couple of questions, and I would like to ask at first that in retrospect, given that the community came back together after 5 years, do you still think having the incompatibilities in 1.9 was a mistake?
I don't think so, because so that we had a very serious issue to handling the Unicode. At the time I designed Ruby in the beginning, so that Unicode is not the mainstream encoding. So that I cared less about Unicode. But time has passed, and the Unicode getting had got more and more attraction, so that we have to handle support Unicode extensively in the language. So we have to do that at the time of the changes. So that we had to make that kind of change in the history. So that it was very serious things, and it caused the community division. But we couldn't help to make that kind of a change.
Thank you. Are we ready to jump on a next question? And the next question is, in your experience, does improving performance in micro benchmarks typically as a side effect translate into better performance for real apps, or do you feel these are not so correlated?
Related to, actually it is related, because the programming language has so many aspects, so that improving the for the micro benchmarks can improve the performance of the real world application. But not the improvement, especially for the improvement for the micro benchmarks, may not be the bottleneck of the real world application. So that so when we improve the micro benchmark by a factor of 10, for example, but your web application or real world application may not improved by that factor, maybe the 10% or 20% or something like that.
Thank you. If you want to jump in for these discussions, please open the stream chat, because we don't have time for all the interesting things on the live stream, but let's continue talking about these topics, because this is why we are here and why we are supporting community discussions. But we have still time for the couple questions, and let me pick up here, like, do you have any statistics in Heroku which would show how many Ruby 2 projects has been upgraded to use Ruby 3?
I don't know. I have less interest in counting numbers and the statistics. But actually, at the Ruby 3.0 was a major release, and it has a lot of changes, so that it could have some breakage and bugs. So that until recently, we released the Ruby 3.0.1, so that the language itself is slightly unstable.
Yeah.
So now I expect people started migrating the 3.0 after the release of the 3.01.
Yeah. So we'll see. We'll see.
We'll see.
And this is quite interesting, actually. Have you seen any increase of new developers in Ruby since pandemic has started? Because things has changed and everything has moved faster. But have you seen new developers?
I don't know, because of the user groups are so isolated, so there are so many so-called newbies, so that are interested in programming and web applications, so that they entered into the world of web application starting from the Ruby on Rails because it's a standard. But at the same time, there are very tech-savvy people who who have shown interest in the newer technology like a JavaScript and Node.js or Dino or TypeScript or whatever. So that for those people, sometimes feels like the Ruby is dead or something like that. But in fact, Ruby is pretty much stable. So that many big players still use Ruby, and the new services are still developed by Ruby. So that I think Ruby is okay, but some people feel differently.
We need to encourage these newbies to join the Ruby community and tell the joy and happiness with working with the Ruby to them. And this is the good that we have the events like this, and we have the community, and we have the gift of Ruby from you, and we can continue to change the world better as you hoped.
Yes.
Let me check quickly. Do we have here? Yes. Is there any specific human-focused feature on Ruby language that impacts performance significantly?
The Ruby syntax itself is pretty flexible.
Yeah.
And then that kind of flexibility make us enjoy programming. So that our language is like the English, Chinese, Japanese, or even Finnish, very flexible, and we can even write very poetic literature or something. And that kind of flexibility is quite a good aspect of the human language. And Ruby itself is inherited that kind of flexibility, so that we can express our feeling, mind, purpose in the very flexible language intuitively. But at the same time, the Ruby's the balance between the flexibility and the computer scientific background makes developers, programmers enjoyable. So that kind of things is the one very good things about the Ruby language. And the second good things, and probably the best things for the Ruby is the community. So that I'm very proud of having this kind of the nice and nice community helping each other. This is very the best community in the world, I believe.
Yes, and the communities like this are really exceptional. And I need to read some greetings from the chat. There's lots of applaud emojis, and here's comments like, "We love you, Matz. Such a nice person you are, and thank you a lot." I think we have time for one quick question, and I'm sorry that I cannot lift all the questions to the stream, but I hope that you will continue the discussion in the chat and later on Discord. Don't be mad at me. It's really good that community is active. Who is the lucky one that has a question? I think we go to the how do duck typing and static typing fit together? How can we prevent that static type kills all the ducks?
Well, the static typing and duck typing are not exclusive. For example, in the Go programming language, they use interface to provide the duck typing. So the static typing is does not contradict with the duck typing, but at the same time, Ruby's duck typing is pretty much rely on the not having type annotation. So that in Ruby, we don't adopt the typed annotation to the language, but we use the type signature outside of the programming, and that kind of type signature written by RBS can provide the interface, which behaves very similar to the Go's interface. So that even if we adopt the static typing on top of the Ruby signature, so that you can still duck typing.
Yeah.
So that you don't have to worry about losing flexibility by adding the static typing to the Ruby language.
Thank you for.
I care very much.
Thank you for comforting us. And actually,
okay, let me add something. So that if we add the type annotation to the language, so that the community forced many people to add the type declaration everywhere. So that means that we lose the flexibility. So that that's why I rejected the idea of adding type annotation to the language.
We have one important question here. Community is wondering how your dog is doing. Doggo, you're doing.
Dog?
Yeah, here's Stefan asking, I wonder how Matt's doggo is doing.
Actually, two years ago, he ran away from my house, but after 3 days, he came back, and since then he stays safe. And whole my family, including my dog and the cat, pretty much safe. Even in the pandemic. Yes.
That's a relief. We need to move on with our program, so we all want to thank you, Matz, with our heart, and the community keeps asking questions. I hope you have time to visit our chat, but if not, community will continue around these topics and encouraging newbies to fall in love with Ruby.
Yeah.
Thank
you for organizing the conference.
Thank you. Of course, it's our pleasure.